Good morning, everyone. This is Sachin Fiske from Electrical Engineering Department, SND College of Engineering and Research Center. Before some lectures, we discussed about the input modules and output modules. Now we are discussing about the analog inputs by using the PLC. So exactly we are using here we are going to study the analog input and analog output modules in system of the PLC. Also, we sample the equipments basically to provide an analog or using the mathematical operation and the standard S7 library function for scaling and analog input boards. Our objectives are to illustrate the principle of operation of analog input and analog output modules. Here we have to write a ladder logic program to read from the analog devices, for example, potentiometer. Also to write a ladder logic program to send analog signals to analog devices, for example, LEDs. And by using a library scale function to scale the value of the analog input. Here, an analog input converts a voltage level into a digital value that can be stored and processed in a computer. There are a multitude of the sensor available which converts the temperature, pressure, etc. into voltage. The computer can then convert the voltage value into the original type and the value can then be stored in a file, emailed to someone or used to control something else outside of the computer. Analog outputs are converting the digital value from a computer into a variable voltage level presented on an output terminal. This provides an adjustable output. This can be used to control the speed of a motor, light and brightness, etc. The operation of analog input modules. The analog sensor produces a difference in resistance, current or voltage which is received in analog input modules and converted into a digital value that is stored in a memory word. The CPU processes the data and generates the digital signal that is converted into an analog output using the analog output module. This value is used to control a specific analog actuator. Basically, figure 1 and figure 2 illustrate the operation of the analog input and analog output modules. See this figure here. The measuring range module, that is MR, is used to change the measurement type and ranges. PI means what? So exactly the PI means peripheral input. Here PQ represents the peripheral output. Note that the analog input and analog output modules use the integer word format to save the data and scaling the analog input value. In general, the value read from an analog input are stored in a memory word, and sometimes you are required to convert these values to an appropriate format to use them in a program in order to do a correct decision according to the actual input voltage. This operation is called the scaling operation, and the first way to scale the stored value is to use the mathematical operation to scale down the input value to its original voltage input value and display it on a memory. See this figure number 3. In the previous program, the input voltage reads from the input data is divided by some value, and when the input voltage is 0 volt, the value stored will be 0, and when the input voltage is 10 volt, the value stored will be 10. The second way to scale down the analog input value is done using the scale function, and in this program object in the left panel expands the library, then standard library, that is T1 as 7, and converting this block section, that is FC105, for the scale the analog input basically we are using. In the ladder logic program, FC105 basically reads the integer value for analog input and stored in PIW 512. For example, the state of the parameter, that is bipolar parameter, determines whether the input value is bipolar or unipolar, because the value of M90 is 0 and it processes the analog input as a unipolar number, which converts this integer value to a real value, as the PLC reads only real value, and FC105 scales the real number to the value in between 0.00, that is parameter LIM, to 10.00 parameter, that is HI underscore LIM. If the function is executed without the error, this FC105 sets the RET underscore WAL, that is MW100. If this integer value is greater than or less than 0, then FC105 sets the output to 10 HILMI respectively. Then FC105 also returns an error by setting this value, and they stored the scales value in MD200. Thank you.